All right, so let's get rolling. Let's get rolling here. So, shut up. So, what we're going to talk about today is we're going to do some FileIO stuff, then we're going to also talk about some JSON stuff. And because Java is a little bit of an older language, they actually predate JSON. So they don't have built-in libraries for working with JSON. They have a couple of things they've added in there you can kind of sort of make work, and there is plenty of third-party libraries that you can download for Java. But why do that when we can write our own, right? All right, so I've actually barely used Boodlebox, so we're going to actually test it here. Um, so so let's see. Well, I don't know. I have access to it. But yeah, so this is the access they gave us when we were testing it. I rarely use it, so I will continue to pay for my ChatGPT and Gemini because they're not equal. Sometimes one is better at certain things than others. That's why like Boodlebox lets you choose here. So they give you access to ChatGPT 5.1, Nano Bananas, Google Gemini's graphic creation thing is pretty good. Claude 4.5 Opus. I don't know who would use ChatGPT 4.0 Mini right now. Oh, actually, I use it for text to speech stuff if I'm writing code. Claude 4.5 Sonnet. They do have Gemini built into here. And it's unclear to me. Maybe their ChatGPT 5 is always the newest version. You also get access to Perplexity on here, but whatever. I'm just going to use ChatGPT 5.1. All right. So what we need is we need to create a data file that we can use to work with um, uh, some FileIO for Java. So we certainly want to have something interesting that we can read in from the file. And then after we learn how to do some FileIO, then we're going to convert that into JSON. So we're going to output it into JSON because that is the format that you will likely be, if you're starting to write code that talks to APIs, which we're going to here pretty soon. When you ask an API for some data, it's going to feed that data to you in JSON. So we need to get comfortable working with JSON. Now, the good news is, and this is the one time you'll probably hear me say Python is better, is Python basically natively works with JSON. So since, in my defense, I did say I code in Python all the time. I'm just telling you it's a crappy language. I still use it all the time. Okay, but it has a huge library of plugins, which is definitely its biggest benefit. Um, and it is highly compatible with the types of things you will be commonly doing. Like, so when you're talking to an API, making a call to some source in the sky and it's giving you your answer, it will always be, nowadays, it will always be in JSON format. So you will need to be good at working with JSON. So us writing our own interpreter and our own parser for it will be good practice of getting used to it. So we need to go ahead and create ourselves a data file. You're going to be doing something very similar. You can choose how to get your data file later. I'm going to try to use Boodlebox to generate the data file that I want to create here, and then we'll just copy it in, and then we'll see how online GDB handles local files and stuff. So what we want to do is we want to get a file that has various pieces of information about stuff that may be comma delimited so that we can now read it in from a file and put it into a JSON format. So I'm not going to ask it for a JSON format now because we're going to start off with FileIO. But what we want to do is we want to be able to maybe do some searching, sorting, whatever. I'm thinking Carnival ships. So we want a list of all the Carnival ships with their gross tonnage and the number of passengers they can hold. Just go with those three things. Okay, you like that? All right. So we're going to ask ChatGPT 5.1, which is the newest we have here in Boodlebox. We're going to say, give me a list of all Carnival Cruise Line. Ooh, here, we're going to do this. Carnival Cruise Line, and it's, looks like it wants that to be 2. And the cruise lines that it owns ships gross tonnage, max passengers. Let's just go with that. And max passengers. All right, give me a list of all Carnival Cruise Line and the cruise lines that it owns, gross tonnage and max ship names, gross tonnage and max passengers. Give me this in a format where each datum is separated by a comma and each line ends in a semicolon that divides the information between ships. Let's see what we get from this. Please, I usually actually do. I haven't decided yet if I want to be so polite to Boodlebox. Because I have not found myself to use Boodlebox really at all. And I've had access to it for a while now. What's taking you so long? Maybe this is part of what's this because Boodlebox is making API calls. So the way that they give us access is oh, it's analyzing my request now, is they behind the scenes have relationships with these various vendors, and they probably have like preferred pricing for per million tokens that they're requesting. So they're actually taking our question. Okay, so now it's giving us our, oh, look at this. We got the Carnival Celebration, the Mardi Gras, Carnival Jubilee. That's a newer ship. All right. Ooh, Seabourn Quest. That's a nice ship. They're not going to let you on there. Totally. Seabourn is like pretty legit. All right. Tiny ships to get into like unique ports. All right, so I'm going to just take that list. It looks like it gave me the ship name, followed by a comma, followed by the tonnage, followed by a comma, followed by the number of passengers, then a semicolon, then off to the next ship. So we have this in a kind of a reliable format, it appears. All right, so I'm going to go into this guy and let me hide. Oh, do we have somebody in the waiting room or something? No. So let me go into the, let me hide floating meeting controls. All right, let me stretch this back out. All right, so let's create a new project. Let's select Java as our language. All right, we have our main.java. We know that I like to rename that to driver.java. That way we don't convince the main method with the class name. So remember that your class name needs to match the file name. So since I just changed main to driver, I need to change my class name to driver. I can test this to make sure it works by hitting run. So there's our hello world. All right, so now I have a working program. Okay, so first thing I'm going to do is I'm going to add a new file, normal file. And we're going to call this ships.dat for data. You can name it whatever you want, but I'm just creating a text file format, and I'll go ahead and paste all those things in there. Oh, I did it all in one big long line. All right, whatever. Let's see if I can do something here. Um, Come on.
Yeah.
And I'll copy it from here. Let's see if I get it in a better format, but doesn't matter. All right. We're not going to come back into this file anyways. We just have all of our data in there. All the data is there. It's fine. All right. So we'll come back to our driver. All right. So now what we want to do is we want to mess around with reading stuff in from a file. So let's go ahead and open up our Java documentation. And I'm going to go to our scanner class, which we have used before to read stuff in from the user, right? So we've used system.in, our standard input stream, to read stuff in from the user. So I'll go to our scanner class here. And we're going to go down to the constructors for scanners, and we're going to see, is there a way to build a scanner using a file name? All right, so here we're looking at our various ways we can put together a scanner. We can build a scanner using a file as our source. We can build a scanner using our file as a source or the character set name. Do we want to use Unicode, ASCII, and then which version of Unicode? There's versions of Unicode to support even larger character sets. We can give it a input stream. Now, I think if we click on input stream here, we'll find that we could also probably build an input stream out of a file. So I'll just jump on that real quick. We'll scroll down here. We'll get to the constructor, or is this an abstract class? It is. So we actually can't create a normal input stream, but we see there is a file input stream, which is an input stream. So I can build a file input stream here, or I can build that guy with a file, or with the name of the file, which is the actual file name. So there's a whole bunch of different ways, it seems like, to open up, to create a file. I'm going to go back here. We're back in Scanner now. All right. So we can just give it the path source, constructs a new scanner that produces value scanned from the specific file at this path. That seems like it might bypass some of those things, kind of do some stuff behind the scenes with us for us to get into it. We have something called a um, readable byte channel, blah, blah, blah. String source constructs a new scanner that produces value scanned from the specified string. So we can give instead of putting that giant string we just copied, instead of putting that into a file and reading from the file, we could actually just paste it in as a string. We're not going to do that. We're going to read from a file here. So let's start off with using our path source. Construct a new scanner that produces value scanned from the specified file. All right, let's start with that guy. All right, so we're going to build a scanner and we're going to use this version of the constructor where we just pass it. Oh, actually, we probably don't want a path source. We want but this is going to come from the string. Do we have, well, looks like we're just going to build a file. This file let us do a string with a path name as a string. Okay, so let's create our file first. So I'm going to go into, where's our thing? I'm lost. Okay. So let's go ahead and do this. Oh, and just real quick, let's make sure, let's see where path lives, or where file lives rather. So file lives inside of java.io. So we need to import java.io.file in order to use that class. All right, that's where it lives. We can see that right up here. All right, and we can also see that file is a normal class, not an abstract class. Remind me, what does it mean for a class to be an abstract class? Yeah, it exists only for the purpose of inheritance, which means we cannot create an instance of it. This guy is not abstract, so we can create instances of it. Okay, where am I again? All right. So up top here, we're going to go ahead and we're going to import. Let me hide this guy. We're going to import Ninja java.io.file. I'm going to go ahead and also import java. Anybody remember where scanner lives? Yep, java.util.scanner. So scanner lives in a library called java.util. File lives in a library called java.io for input output. All right, so let's go ahead and let's build ourselves our file. The constructor said we could just give it a path. Now, fair warning, sometimes when you're working with online sources like this, the way they handle like the directories behind the scenes can be a little sketch. So it's possible we might have to do a little debugging here to figure out how do we reference the local file system. But my hope is that we can just give it the file name and it checks in the local directory first. Let's see if that's a true statement. So we'll say file f is equal to a new file. And then it wanted us to give it the name of the file as a string. That was one of the constructors. If you remember from down here, one of our constructors out of many. So we have 4 different ways we can build a file. What does it mean to have the same name of a constructor, but a different number or type of parameters? Polymorphism. All right, so here's an example of polymorphism. We can build files 4 different ways. All right. So we're going to use the this way one, where I give it a string with the path name. All right. And our file name is called ships.data. So let's just try giving it, or ships.dat rather. Let's try giving it there. And then let's see, what can a file do to maybe tell us if it read in the right thing? So let's look at some of the abilities of a file. Returns the length of the file by this abstract. Oh, so maybe that gives me the number of bytes. Let's see if that gives me the number of bytes. Oh, whatever. Let's just see if it crashes when I try to build it, because we're going to put it into a scanner pretty quick. All right. So let's just go ahead and run it and see if we get an error rate from the get-go. Okay, so far so good. So now let's go ahead and build our scanner. If you remember, scanners can be built with a file. So I'll say scanner input is equal to a new scanner, and I'll pass it F. I'm going to build a scanner using a file. Now, it's possible that's going to give me one of those things where it yells at me and says that this potentially has I mean, we can look at it pretty quickly, but let's just test it real quick. It'll yell us if it requires us to deal with an exception. All right, so we have a file not found exception. It must be caught or declared to be thrown. So since we can just assume right now, and since we don't practice with tries and catches very often, it's yelling at us right now. It's saying, look, we know since the line we just added was a scanner one, that guy potentially throws an exception that says, I didn't find the file. It's possible. So we're going to try to do this stuff. And then catch the potential exception. And then we could do something like a system.err.println e dot, I think it's, well, here, I'll just do e. It'll give me enough of it. There's like an e.print stack trace or something like that. All right, let's run this now. Okay. So at the very least, we didn't get an exception, so it seems like it found that file. All right, so now let's go look at scanner. Let's see if we can start getting some of the contents of our file to spit out. Go ahead.
What is try and catch?
So try says I'm going to try to do something that has been advertised to me by the programming language that it might throw an exception. If we go into the documentation here I ultimately want to get to scanner. So I'm going to say Java scanner class. Here's scanner. We're going to go to our constructor for scanner that takes a file as a parameter. And we see here that this scanner throws something called a file not found exception, which means that as it's trying to build that scanner, if the file it's trying to build that scanner around is not found, instead of your program just crashing, it's going to throw this exception saying, I didn't find a file, allowing us to deal with that exception and then either have the program recover if it's recoverable, or at least crash in a majestic way. Probably not like you went down the other day. Carnival. Was it in a you you blacked out in somebody else's room? Yeah, he doesn't remember any of this. This is all recording, so you'll have evidence. All right. What's up? You're gonna see. Yep. All right. So now we have our scanner. It seems to not be screaming at us about the file. So let's see if we can get some information about this file, or at least start reading stuff in. So let's scroll down on our scanner, and that we have one built. Nope. Looks like I'm already in the. Okay, so let's go down here, and here's all our things we have. So we can ask if the scanner has a next. Let's go ahead and read in the next string. So we have something called do we have a has next string? Has next line. Returns if there's another line in the input of this scanner. All right, so let's ask that question. We're going to say if input dot has next line. And just to see that we're calling this the correct way, when we go into scanner, we see has next line right here. This guy does not have the word static over here. So since it's a non-static method, it means it belongs to an instance of the class. We need to have an instance of scanner in order to call this ability. All right, we happen to have an instance of scanner called input. And now we're going to use input to call has next line. It's going to give us a Boolean whether or not there is a next line. And if there is one, we're going to go ahead and get the next line right down here. And we're going to go ahead for right now, we're just going to print it out. Next line gives us a string. Let's find out, is it reading in the file as a whole rigmarole or one line at a time? Doesn't really matter. We can build up a string containing the whole rigmarole if we want. Let's just see what we get. All right, so we'll go back in here. We're going to say if input dot has next line, if that's a true statement, we're going to go ahead and do a system dot out dot println input dot next line. Same thing we used when we were reading in from the keyboard, except this time we're reading in from a file. So we'll go ahead and print that out, and we're going to keep doing that. Actually, let's do a while here. So while input dot has next line, let's print out the next line. So as long as there's a next line, we're going to read it in and display it. All right, let's see what we get from this. All right, let's actually also, it looks like it got all that in a single go. Let's do a system.out.println line, something like that. Let's make sure we only see one of those guys at the end. And we do. So it's reading the file in as a one big long string, the way we're getting it here. Make sense? All right. So now we purposely put little semicolons between our information about our deal, right? Okay, we purposely put semicolons there. So we could go ahead and take that line and split it on semicolons, because we know that there are semicolons inside of that's dividing up our individual ships. Now, I'll tell you that the string class has a split function. that you could pass it things as passes it regular expressions, which allows you to really describe patterns you're looking for. We're going to go with the easy version of this. So we're going to say string array. I'm going to call this guy the parts is equal to input dot next line, which this whole thing here will be a string, right? I'm going to take that string and we're going to split it. So I'll just show you down here. If we go into the string class here, we scroll down. We're going to see that we have, among a whole bunch of other things, we have one called split that takes a regex as a parameter, probably. I think that's what it takes. Yep, here's split. So we can take, it takes a string regular expression as a parameter. So if you go and learn about regular expressions, you find out that these are pretty complicated things. You can really match very specific things. So regular expressions are powerful. We're not going to take advantage of any sort of its power. We're going to say split on a semicolon, and it's going to split it on semicolons. All right, so that's what this guy does. And notice it gives me a string array as a parameter. So it's going to say, I'm going to say split on semicolons. It's going to give me from that giant string 1 bucket per a ship name, comma, gross tonnage, comma, passengers. That's going to be a single string entry into bucket 0 of my string array. Bucket 1 will contain the next ship pieces of information, so on and so forth. All right. So go back to our code here. Now, what we're showing here is something that is going to be a very, very, very common use for you as code slingers, right? We go through life. We have the ninja abilities to wield programming languages to do stuff. It's going to be very common for people to have this giant wall of data that they don't really have anything they can do with, yet we do. As long as we can get it into a program, and as long as we can get it into a format we can work with, like a string, we could do anything we want with that guy. All right, so we're going to have our parts here. And then we're going to go ahead and, since we know this is only going to give us one thing right now, we'll just switch that to an if statement. That way we don't have to worry about it going through multiple times. It's just going to work. All right. So we get our next line. We're going to say, I want to take this string. We could put it in a variable if we want. But in this case, we don't need an intermediate variable. We're just going to say, I want to take that string, and I'm going to, which is an instance of string. And we're going to call, using that string, to call the non-static method called split. And I'm going to say, I'm going to split on the semicolon. All right, and that's going to give us an array of parts. The parts of this giant string that should be 1 ship per part. All right, now we're going to go ahead, we're going to create a for loop for int I is equal to 0, I is less than, how many elements are in the parts? I feel like I keep asking the same questions. How many elements are in the parts? Length, number of elements. The parts dot length, number of elements, and that is a field, not a method. We know that because we don't put some parentheses on the end of it. Strings length has a parentheses on the end of it, so they happen to implement strings with a length method. They happen to implement arrays with a length field. They're both still giving you the same value, the number of things in this collection. All right, technically, arrays say, here's the number of things this collection is capable of holding, not necessarily a number of actual things that are in it. Where a string is going to say, here is the number of characters contained within me, including spaces. Because strings, it doesn't make sense to say this string is capable of holding this many things. We don't build strings that way. Strings just are their length. All right, so we're going to go from I is 0, I is less than the number of things, I plus plus. And then we're going to go ahead and we're going to do a system.out.println the parts. at bucket I. All right. So now we should see our information one boat per line, right? So it's going to start looking a little cleaner for us because now we've gotten into our program, we can start doing different things with it. All right. So understand that now that we have data coming in this case, that data came in from a local file. But this is going to be the same type of thing we're going to be working with if you get your data from some cruise line API that's out there and you send it a request for give me all the Carnival ships, and then it sends you whatever information it has. These are all just data sources. So when you hear somebody talking about an API or you look up at some, whether it's an Amtrak station or a flight schedule, whatever it is, there are things out there called APIs. And these APIs are effectively a bunch of function calls. You'll usually see them called as referred to as endpoints. Okay, so you might call upon using our joke thing here, and he's frankly not being that great of a sport about it, but we're going to keep hitting him with it. But I tease him because he is a good sport about it. Some point I'll tease somebody who might not be a good sport about it, because then the rage starts in the classroom, especially after midterms. Man, these students get violent. I don't know how the smaller stature teachers handle it. Well, I mean, you got to be really serious on follow through to like attack someone my size. But if you get someone you like know you can roll through, what's up? By yourself? Well, you're probably not scared, and you might be stronger than me, but I am way bigger than you, so you better come in with intent to get me down. And then you got to make sure once I'm falling down like a tree that you're not underneath that. That's my ninja move. I just go 2-year-old. I just go dead weight on you. You try holding up 350 pounds of dead weight. You what? You might be able to. No, I'm not. I'm built for. I don't hold together that well anymore. All right, so we're going to read in all our parts, or we're going to read in all the things in the file into this string. Once we get it into our program, doesn't matter where that data came from. We can now work with that data. So let's just make sure we're splitting it up on those semicolons. We were very specific of how we organized our data, right? But we are very proprietary. If we were to give this file to someone, we'd have to tell them, oh, by the way, each piece of information has a semicolon splitting it up. We'd have to give them that information. Where if we were using a standard like JSON that we're going to work with, all of a sudden we no longer have to like tell you about the data. The data describes itself in JSON. So that's really what we want. That way, every single API doesn't have to have, this tutorial on how do you talk to our data. They all give you the data in JSON. You talk to it like you talk to any other JSON. So you can write some code that will literally work with any API. You just swap out a couple of things. Some APIs are fully public. You don't have anything extra. Some require like an API key. So you just swap out whatever the API key was for the last place you were talking to with the one for this one. So if you were dealing with Carnival, you might say api.carnival.com/ships. And that might be the endpoint on it. And then it gives you a list of all Carnival ships. Ultimately, it gives you the stuff we've put in our file, except it'll give it to you in a better format than our ghetto format that we've worked with here. Go ahead.
So what is JSON typically like?
Well, I just described it. Like one thing might be to give you consistent formatting for data across different domains. Whether I'm talking to a cruise line or a flight schedule or whatever it is, I'm getting my data from somewhere. If that data is in JSON, it's already organized. From a Python perspective, JSON is a dictionary. It's a collection of name value pairs, and values can also be arrays. And we'll talk about the details of it in a second. So let's go ahead and let's see this guy get into our data. All right, so now you see we have our individual, here's the name of our ship, comma, here's our gross tonnage, comma, here's our number of passengers, right? Okay, so now why don't we go ahead and build some information off of this? So we know that we want to hold information about cruise ships. So could we build a class called cruise ship? And given the information that you see we have here, what fields would you have in that class at the very least? Yep. So we're going to have 3 fields to hold the information about each cruise ship. So let's go ahead and let's build a file called cruise ship.java. And I'll go ahead and steal that spelling. All right. And this is going to be class cruise ship. Now remember, all programs begin and end with main, and we already have inside of driver.java our main. So we don't write a main in our other classes. We have one file that drives our program, hence me calling it driver instead of randomly calling it main, which is just stupid, to be frank. All right, so we want to have a couple of fields. So we're going to say we're going to have a private string ship name. We're going to have a private. Now we can decide how to store our gross tonnage. We can decide, do we want to store it as a string? Do we want to store it as an int? Typically, gross tonnage will be given as a whole number. We don't know if we're going to do math with it or not, but we might. So let's store it as an int so we can deal with what if we want to do that. So we're going to say int gross tonnage. All right. And then the last thing is the number of passengers. So also probably an int. Let's call this guy max passengers. All right. Now are we comfortable using an int here? Or should we use a long, and why? That's already a big number. Okay. Once they start growing or building cruise ships that are over 2.1 billion tons, then we can expand it to a long at that point. Right now, the largest cruise ships on the planet, you know how big they are in tonnage? They are about 255,000 tons, are the biggest ships on the planet. Those are the Icon class ships from Royal Caribbean. Yeah, I've been on, we just got off of one of them. The Star of the Seas just came out. The next group is the Oasis class ships that have been out for a long time, and they're about 230,000 tons. So both of them are larger than every other cruise ship's largest ships. That's just what Royal Caribbean is known for, is those super ships. Okay, so now we have this class called cruise ship. It's going to have, split up these pieces of information. Now, what format do we currently have these 3 pieces of information in? Well, no, I mean, so these guys down here, what format is this guy in? It's a string, right? This is a string that we can tell has comma delimitations in it, delimiters in it. All right. So to build a cruise ship, we're going to give it a string, and then inside here, we're going to go ahead and split it up to keep our hide the details, encapsulate the details inside the constructor. So we're going to say, remember, the name of our constructor is the same name as the class name. Why don't constructors have return types? Yeah. All methods have return types. Why don't constructors have a return type? They're not void. If they were void, we put void. No, they're not a method, but they look like methods. So why don't we put anything to the left of that? Constructors are always used when you're creating an instance using the new keyword. And what does the new keyword do? Gets us memory. New keyword is like our real estate agent. It goes out, negotiates with the operating system, comes back with a pointer to a place in memory big enough to hold the thing you were building. Okay. We don't have a return type for constructors because the return type is always a memory address. Why write it if it's always going to be a memory address, right? Some older languages have you write it. You do write it, and you always write the same thing. You just copy and paste it. Some uh, compilers, some IDEs, integrated development environments, will have these things that are called snippets, where you can kind of create your own little like templates that you can just hit a button and it'll like put your class template out there or something like that, or a for loop template, things that you kind of write often, but they all kind of look the same. You just plug in a couple of values. All right, so we're going to say a cruise ship is going to take in a string as a parameter because that's the format we have it in. We're going to work with that string in here, but it takes a string as a parameter. So the first thing we're going to do is we're going to go ahead and break that string up on commas, right? So we're going to say string array, I'll call this guy the parts too, is going to be equal to s dot split on commas, all right? So that's going to give us our parts. So now what we expect to get from this, just run this again real quick so we see, we're going to expect to get bucket 0 being the name of the ship, bucket 1 being the gross tonnage, bucket 2 being the number of passengers. Okay, so we have to, when we're sending data around in this unstructured way, in a way that isn't a standard, we have to remember that the data is in that specific order. All right. JSON does not require us to have in that specific order because JSON describes itself, and we'll see that. All right, because we're going to be producing a JSON version of this here in a second. All right, so I'm lost. Okay, so we're back in here. So now we have this array of parts. And we can go ahead and split, print each of these parts if we want. So we can say for int I is equal to 0, I is less than the parts dot length, I plus plus. So you might want to do this as you're working on your program, is make sure your data is the way you think it is along the way, so that when you finally get down to your logic, you know you're working with the right stuff, rather than making some assumption from 11 classes ago that, oh yeah, I'm working with a collection of strings here, when you're actually working with 10 numbers because you made the wrong function call or something. So don't be ashamed to print out values along the way as you're testing, as you're building, to make sure that the stuff you think you're working with is the stuff you're getting. All right, so we're going to go ahead and we're going to print out the parts at bucket I. So now for each of these guys, we should see ship name, then in the next line, gross tonnage, and the next line, number of passengers. And if I do this for every single one of my cruise ships, and notice this is in the constructor. So as I'm building a cruise ship object, it will print something to the screen. I don't have to call an extra function later on to display itself or something. Because I put this code right here, I put it inside of the constructor. All right, so now that I have the ability to create cruise ships and the constructor is going to spit some stuff out, I'll go back into driver. And rather than printing these guys, I'll go ahead and say, for right now, let's just do, we'll do that. We'll just build a local variable of type cruise ship. We'll store it inside of CS for now. We'll change this in a second. And it's going to be a new cruise ship, passing it the string that is the parts of this particular cruise ship. All right. And we know that this constructor right here, notice it comes right after the new keyword, always returns a memory address. But we know that this constructor, if I hand that guy a string, he will split that string into, we know it happens to be 3 pieces, and then display 1, 2, 3. So if I print out or if I run this program now, instead of getting a whole bunch of lines that look like this, I'll get 3 lines per one of those with each piece of data right on top of each other. So this is going to prove that I'm working with my data in a reasonable way. All right. So I've reformatted my data. It's in my program. I could do all sorts of stuff with it. Make sense? Now I can, since these guys are private, I can, instead of displaying here, I can go ahead and just set my fields, right? So I'll say this dot ship name, and ship name is a string. So this guy is going to be the parts at bucket 0. We know that's where the ship name is stored. Now, depending on the split function you're working with, it may or may not give you a string without any extra spaces on either side. So let's see if split tells us it does that. Splits a string around matches given a regular expression. Let's see. The given expression and a limit argument of 0. Trailing empty strings are therefore not included in the resulting array. Okay. All right. I don't see in there that it actually guarantees that it will get rid of spaces on either side. Most programming languages will have a string function called like trim or similar that will just cut off any white space on either end so that you know you're only dealing with your data. This would be a good time for us to make a call to trim, which just returns for us a string whose value is the original string with any leading and trailing white space removed. It's handy. All right, so now as we're capturing our stuff here, we're going to go ahead and we're going to grab the trimmed version of that string. That way we don't have any extra spaces in case we do some stuff with this later. Okay, so we don't need to do anything special to that because it's already a string. Now, at this point, the parts at bucket 1 and the parts at bucket 2 are also strings, but I actually need them in something else, like an int. All right, so I'm going to say this dot gross tonnage is equal to the parts at bucket 1 dot trim. Okay, so that's gonna, this guy over here right now is going to give me a number stored as a string without any extra spaces. I need to get that guy turned into a number. Go ahead.
Why are we like part of the indexes that
Yeah, we invented our format, so we have to hard code it. Yeah, JSON's not going to require us to do this. So we're showing the old way of doing something like this. But we're going to create JSON out of this because we might just have raw data we're working with here. And then we probably could have asked ChatGPT to give it to us in JSON, but what fun is that? Yeah, so we'll write it ourselves. All right, so now we have our a number like this, for example, but we have it as a string. We need to get it as an integer. So we need to find out in the language we're working with, pretty much every programming language will have something built in that allows you to convert between types, as long as it makes sense. So remind me, what are primitive types? So an int is a primitive type, right? So what is a primitive type? What designates something as being a primitive type as opposed to an object type? Okay, so primitives are built into the language and they can only hold a value, which means they don't have extra abilities. Okay, so right now we have an int, and an int is a primitive type. Well, really what we have is a string. String is an object type. So if we want to convert a string to an int, we can start off by looking at strings and say, does string have a way of just saying get int or something like that? I happen to know that inside of Java, we have something called the integer class. I think I probably showed this at some point. If we go to the core Java Lang, let's just go, let's go to overview maybe. Will that give me my classes? Class tree. Will that give me what I'm looking for? Oh, perfect. Java.lang. Yeah, that's going to give me what I'm looking for. Here, let me just do this. Java integer class. So inside of java.lang, there will be a list of classes that all associate with our primitive types. Since primitive types can only hold a value, and we might sometimes want to do other things with those primitive types, we have classes for each of those primitive types to do those other things. So inside of integer, we have a method called parseInt. Looks like we have a get integer, but we have something called parseInt. Oh, we have an int value, but we want to work with a string. Okay, so this guy parses the string argument as a signed decimal integer. All right, so parse int, we pass it a string, it gives us an int. But notice that this guy is static, which means he is owned by the class itself, not an instance of the class. So it's kind of like there's a single factory in downtown that if you have a string representation of an int, you can walk into that factory, hand them your string, and they'll hand you back an int. That's how this works. So in order to call this guy, we have to use the name of the class in which he's defined, and he's defined inside of the integer class. So we'll come up here, and in our cruise ship code, we're already getting the trimmed version of that string. So what we'll do here is we're going to say integer.parseInt of that guy. So now we're going to convert that trimmed string into its int equivalent. Now that only works if it actually is an integer. Don't try to like convert hello into a number. You'll get an exception, a runtime exception. And then we're going to say this dot max passengers is equal to integer dot parseInt of the parts at bucket2 dot trim. All right. So now we have our, we've read in our 3 attributes. They are private. So if I want to give ourselves access to those, I'm going to have to create like a public string get ship name. This guy will return this dot ship name. Ay, ay, ay. Public int get gross tonnage. Return this dot gross tonnage. And public int get max passengers. Return this dot max passengers. All right, so we made all of these fields private, which means we cannot access them outside of this class, but then we gave ourselves public getters. So these allow us to, these are just normal functions. We just happen to be using them as something called a getter, where it will get us the value of an internal private field. This gives it to us as read only. We can't change it. As opposed to if we made them public, those fields, we can read and write those fields. Okay, so what we're saying is this, look, a cruise ship, these pieces of information are what they are. You don't get to go in and edit the name of the ship or edit the gross tonnage or whatever. If that was going to happen, it would happen at the point of our data source. Okay, so we're going to make it so you can't change this data here, but we'll let you view it. That's why you make things private and only loosen those reins if you need to. All right, so now that we have the ability to do this, when I create my cruise ship, I can now do a system.out.println cs.get, we call it get ship name. So now all we're going to do is print out that one field of that guy, proving we have the access to the ship name. Did I not return it, or do I have an error? Oh, it's testing you. You failed. Hey, look, I'm just calling them the way I see them. So there's a list of just the ship names. All right, so we're convinced that we have access to our data. We can wield it any way we want, blah, blah, blah. All right, so now if we were working with this data as actual JSON, what we would have is a top level JSON object, opening and closing curly braces. That's your total object. And then inside that, you would have an array. So if we were writing this by hand, I'll just do it on the next line. Is that the end? I'll just do it on the next line down. So we would have something that looks like that. We would then have something that looks like that. And then inside here, we would have JSON objects representing our ships. So we might have a object that has ship name, and these are usually in as strings. Ship name, colon, Seaborn Ovation, for example, and then comma, gross tonnage, and I'm just going to make something up here. Notice that I'm storing it as a number. JSON lets you support types. And then we're going to have max passengers. And let's do 400 for this. Right, then we have another one. I'm just going to actually just copy this. This to the Sojourn. And this is 1480. And let's call this 250 passengers, something like that. All right, so even though that only has 2 ships in it, we ultimately want to produce something that looks like that. All right, so this is every single JSON object lives between an opening and curly brace. Now, if you only had a collection of JSON objects that mean different things, you can create an object followed by an object followed by an object, but we know that we have this big collection of objects and we want to get those guys as arrays. We want a collection type. So JSON supports the idea of an array. And notice that it uses very programming familiar symbols for collections. So we're used to opening and closing square brackets for arrays. This says, hey, here's an array of stuff. Well, what kind of stuff do you support? I support arrays and I support objects, JSON objects. So can I put an array inside of an array? Sure. You can put anything that is of type JSON object, which is either a JSON object itself or an array of JSON objects. Following here? All right. So ultimately, we want to produce something that maybe looks like this. Okay, so we want to have a function that maybe goes through all of our cruise ships. And we call this public void. Actually, let's just do public string to JSON. I will capitalize the whole thing. All right. And what we want to do is we want to go through this whole thing and we want to produce the JSON that is our file. That is the JSON representation of the stuff from our file. All right. We know it's going to start with an opening curly brace. We know it's going to end with a closing curly brace because we know that the JSON we're working with here is a collection of stuff, but every single JSON object starts with, so we could say string answer starts off with, we'll just start it off with an opening curly brace. We know at the very end, we're going to say answer is equal to whatever answer is currently equal to plus a closing curly brace. That will be the end of our object. Now we know in the middle, we're going to have to process some stuff. We happen to know we're working with an array of things. So we know that we can also put a opening square bracket here. We also know that we can put a closing square bracket here. We know the nature of this kind of object. Okay. It's going to be a collection of things. Now, what things is it going to be? Well, it's going to be the things that are inside of our array. So we're going to say for int I is equal to 0, I is less than this dot the, did I call it the parts? Oh, actually, I don't have them stored as an array up there. This is just an individual cruise ship. So this is an individual cruise ship, not a collection of cruise ships. So since it's an individual cruise ship, it's not a array yet. It's just a plain Jane object. And what's inside this? This is going to be 3 things. We don't need a loop here. All right, so for these 3 things, what are we going to do? We're going to tack on to answer those 3 pieces of information. So we're going to say answer is equal to answer concatenated with. Now we want to give it our ship name, but it needs to, we're going to describe it as ship name. So it's going to, what's going to get added to it is ship name, colon, actually ship name like that. Why does it want to complete those things? Okay. So ship name like that. We have, when we put those backslashes there, that's an escape character. It says actually include those double quotes inside the string. Don't treat them as finishing the string. So these are escape characters. You've probably seen me use it before where I did like a backslash n, where that kicks it down a line instead of trying to display n or something like that. All right, so we're going to be building our string. So ship name that, and then the value for that is our ship name. So we'll do a similar thing. So we'll say that concatenated with this dot ship name concatenated with backslash that followed by a comma. And that string, then concatenate onto that our name of our or our gross tonnage and our max passengers. These don't have to have the double quotes around them because these are actually numbers, but the names themselves have to have the double quotes. Okay, so we're going to say backslash gross tonnage backslash colon this dot gross tonnage concatenated with a comma concatenated with backslash max passengers. I'm just naming it max underscore passengers. You can call it max passengers with capital P. You can name it whatever you want. This is just a string. This dot max passengers. And then we can go ahead and end that. All right, so we're getting our answer, opening curly brace. Here's all the stuff in between. So ship name equals the ship name. Gross tonnage equals the gross tonnage. Max passengers equals the max passengers with commas after each of those. And then the whole thing ends with a semicolon. So we can then return answer. So now we have a to.json for each of those. So I can come out here, instead of doing print it out, I can do a cs.to.json. And now I run it, we're going to get a whole bunch of independent JSON objects. Let's see, max passengers colon concatenated with this dot max passengers backslash that backslash that. What are you upset about? Oh, does it? Oh, gross tonnage. Oh, thank you. After I sit here and tell you that it helps you not have typos, it still name the things differently. I left a semicolon in the middle of it. I mean, I'm sure you're right. Gross tonnage. Oh, this guy, thank you. All right, so we see for each thing we have ship name. Here's your seaborne crush. You have gross tonnage. Here's this guy. You have max passengers. Here's this guy. So what I'm going to do is I'm going to give you this code as your starting point, and I want you to have the entire thing output to another file, the JSON representation of all this data, which means you're going to effectively wrap all of these inside of opening and closing square brackets, because this is an array of JSON objects, and then you're going to display it, or you're going to print all that or write all that to a file using the reverse logic of what we did today. Go and learn how to write out to a file. Make some sense? I'll give you this code as a starting point. Questions, comments, concerns, bribes? Okay, I will see everybody on Tuesday. We're going to chapel front row. You're welcome to join us. Then we always do lunch, I think, at around 11:30. You're also welcome to join us at our big table that we usually get. It's a free for all.